Lesson 14, the volume of a sphere. Now, the region bounded by the circle x squared plus y squared equals r squared, this one here, right? The x-axis and the y-axis in the first quadrant is revolved around the x-axis, as indicated. We have to determine the volume generated, and hence show the volume of the sphere is 4/3 pi r cubed. So we'll revolve this one around here. To work out the volume of the sphere, we'll just double our answer. Now, again, a little bit of theory. We can take this section here and revolve around that. Right, now this will be of height dx, and this will be y. So our dv will be equal to pi times the radius this time is y squared, and it'll be dx. Right, so setting that little one up, we're going to have that the volume equals pi integral of. Now, what are the limits we're going to use here? Right, now the limits are simply going to be from naught going revolving this way. We're going to go from naught to r. That's the r there. So it's between naught to r, and moving that way, naught to r, and that's going to be y squared dx. Now, from here we can see that y squared equals r squared minus x squared. Now this r is a constant, right? It's fixed. You could choose it to be anything you like, 2, 3, whatever, but that's fixed. So our volume then is equal to pi integral between r and 0 of r squared minus x squared dx. Now, that's going to be equal to pi. Now, integrating the r squared, we're going to get r squared x minus x cubed on 3 between r and 0. So our volume is equal to pi outside of, putting the r in, we get r cubed. This becomes minus r cubed on 3, minus, of course, just 0, which is, this becomes 2/3 r cubed, so that's 2/3 pi r cubed. And that's the volume of the section here. So the volume of the sphere is going to be just twice this, 2 times 2/3 pi r cubed, which is, as required, 4/3 pi r cubed. And we've shown that the volume of any sphere is equal to this particular formula.